Dear students, welcome back to my channel Enjoy Learning. In this video, I'm going to explain chapter 1 of class 10 real numbers. So the first topic in this chapter is the fundamental theorem of arithmetics. So what does this theorem says? It states that every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Now it sounds a little bit difficult, but don't worry, I'm going to explain you each and every word, each and every line of this theorem. Okay, so first of all, I'll explain you the basic terms, that is, what is a composite number, what is a prime number, and what do you mean by factors. So if you already know the meaning of all these three words, then that's very good. You can skip this part of the video and move ahead. So starting from what is the meaning of a factor? What is a factor? So I'll explain you by giving an example. For example, what are the factors of 8? So just listen very carefully. Factor of a number is the number in whose table that number comes. Means factor of 8 is the number in whose table 8 comes. So the numbers in whose table 8 comes, what are the numbers? Starting from 1. So we know that in the table of 1, every number comes. 1 zeros are 0, 1 ones are 1, 1 twos are 2, 1 threes are 3, 1 eights are 8, and so on. So 1 is the factor of every number because in the table of 1, every number comes. So what are the factors of 8? The numbers in whose table 8 comes. So starting from 1, in the table of 1, 8 comes. Next, in the table of 2 also 8 comes. 2 fours are 8. Next, in which table 8 comes? In the table of 4. 4 twos are 8. And the lastly 8. So what are the numbers in whose table 8 comes? They are 1, 2, 4 and 8. So these are the factors of 8. I hope you have understood the meaning of factors. What are factors? Factors of 8 are the numbers in whose table 8 comes. So in the table of 1, 8 comes. In the table of 2, 8 comes. How many times? 4 times. 2 fours are 8. In the table of 4 also 8 comes. And in the table of 8, 8 comes. So every number is a factor of itself. Remember these two key lines. Okay. Every number is the factor of itself and 1 is the factor of every number. Next, what is the meaning of composite number and prime number? Now you can very easily understand the meaning. So what is a composite number? A composite number is a number that has more than two factors. What I said? A composite number is a number that has more than two factors. So let's just quickly see the factors of 8. How many factors is 8 having? 8 is having 4 factors. How many factors? 4 factors. So what is the definition of composite number? A composite number is a number that has more than 2 factors. So see, 8 is having more than 2 factors. There are 4 factors of 8. So a composite number is the number that comes in its own table, in the table of 1, and apart from these 2 factors, it also have more than them. More than 2 factors. Next, what is a prime number? A prime number is a number that has only 2 factors. What is a prime number? Prime number is a number that has only 2 factors. For example, 5. See, 5 only comes in its own table and in the table of 1. Can you find any other number in whose table 5 comes? No. Similarly, 2. 2 is also a prime number. 2 comes only in its own table and in the table of 1. In no other table it comes. Likewise, 3, 7, 11, 13, all these are prime numbers. So I hope you have understood the meaning of composite number and prime number, their difference, right? Composite numbers are the numbers that come in their own table. They also come in the table of 1, But apart from these two factors, they also have at least one more factor, right? They have more than two factors. And all the numbers that are having only these two factors means they only come in their own table, and in the table of 1, in no other table they come. So they are called prime numbers. So examples of composite number you can also very easily figure out. Composite numbers, they are 4, 8, because 4 comes in its own table. It comes in the table of 1, but see, it also comes in the table of 2. So 4 is also a composite number, 8 is the composite number, and you can find many other such composite numbers: 4, 8, 10, 6, 12, and so on. Similarly, what are the examples of prime numbers that also I've just mentioned? So let me write here: 5, 7, 11, 13. You can also find many other examples. Next, quickly move on to the meaning of this beautiful theorem. Now we have understood the meaning of all the basic terms involved here. So every composite number, what is the meaning of this theorem now? Every composite number can be expressed as a product of primes. So let's just understand till here. Every composite number can be expressed, means it can be written as a product of prime numbers. So let's just quickly take a composite number and then we'll prove this theorem on that number, and you can very easily understand what does this mean. So I have taken the same composite number 8. And what is this theorem saying? It is saying that we can express 8 as a product of primes. Means we can find prime numbers such that when we multiply those prime numbers, we will get 8, right? Product means multiplication, answer of multiplication. So when we multiply prime numbers, we can find the composite number. So we can write any composite number as a product of primes. So let's find how can we write 8 as the product of primes. What is 8? 8 is 2 4s are 8. Shall I write here 2 4s are 8? But now 2 is a prime number. But is 4 a prime number? No, 4 is not a prime number. 4 is a composite number. So this is not the expression that is mentioned in this theorem, because 4 is not a prime number. So what is a prime number? What can I replace here in place of 4? Can I write 4 as 2 into 2? Because what is 4? 4 is 2 2s are 4. So we can also write 8 as 2 into in place of this 4, because we have to write 8 as the product of primes. So in place of 4, we will write 2 into 2. Now see, 8 is equal to 2 into 2 into 2. We have found this expression. We have written 8 as the product of prime numbers only. See, 2 is the prime number now. And 2 to the 4, 2 is 8. So the first part of this theorem, this we have understood. I am also giving you one more example. Let's write the example for 18. Okay, so 18 is also a composite number. We can write any composite number as the product of primes. So just quickly write, what is 18? 18 is 3 6 are 18, right? 18 is 3 6 are 18. But now here we have to write 18 as product of primes only. So 3 is a prime number, we know, but 6 is not a prime number. 6 is a composite number. It comes in the table of 2 also, 3 also. So it is not a prime number. It is a composite number. So we have to replace 6 by some primes. So how can I replace 6? What is 6? 6 is 3 2s are 6. So we can write 18 as 3 into 3 2s are. In place of 6, we have written 3 2s are. Now this is the expression that we are talking about in this theorem, that 3 3s are 9, 2s are 18. This composite number 18 is written as the product of prime numbers. Okay. Now this expression that we have found for our composite numbers, this is called factorization. What is it called? It is called factorization. Why? Because see, factorization is made from the word factor. So see, We have written 8 in terms of its factors. We have written 8 as a product of factors, and that too which kind of factors? Prime factors. So this is in fact called prime factorization. The new term, all of you have understood what is the meaning of prime factorization. Means we have written the number as a product of its prime factors. See, all these are the factors of 8, and they are also prime. So this can be called as prime factorization of 8. Similarly here, this is also called, this expression for 18 is called prime factorization of 18. Prime because these are prime numbers, and factorization because these are the factors of 18. Next, move on to the next part of this theorem. I hope you have understood the first part of this theorem. Next, what does this theorem says? And this factorization is unique. This factorization is unique means this expression that we have found for 8, this is unique. We cannot find any other such factorization, means we cannot write 8 as a product of some other prime numbers. No, this factorization is unique. 8 is always written as 2 into 2 into 2. Nothing else than that. You cannot write 8 as the product of some other prime factors, like something like this. No, we cannot write like that. The only factorization of 8 is 2 into 2 into 2. So every composite number has a unique prime factorization, right? Every composite number has a unique prime factorization. We cannot replace the prime numbers in this factorization by some other prime number, right? This factorization is unique. This is the second part of this theorem. Now the third part and the last one. Apart from the order in which the prime factors occur. What does this mean? This means that this prime factorization of a composite number is unique apart from the order, means except for the order in which the prime factors are written. Means we have just now understood that this factorization of composite number is unique, means 18 can only be written like this. We cannot replace these prime numbers by some other prime number, by some other number. So this factorization is unique except for the order in which the prime factors are written. What does this mean? This means that now, yes, you can change the order of the prime factors. How the prime factors are written, you can change their order, but you cannot change the prime factors entirely. It means you can write it like this. You can bring this 2 in the middle or to the beginning. You can write 18 like this also. So the numbers, the prime numbers that are written in the factorization, they are unique. You cannot change the numbers. You cannot change the prime factors. But yes, you can change the order. You can change their order in which these prime factors occur, means in which they are written. So the prime factorization of a composite number is unique except for the order in which the prime factors occur. Means the order can change. This is also the prime factorization. This is also the prime factorization. This is also the prime factorization of the same number 18. What is there? We have only changed the order, but we have not changed the prime factors. Okay, just have a careful look on these expressions. So this is what the theorem says. We have understood the entire theorem, that every composite number can be expressed as the product of primes, and this factorization is unique. This factorization is unique. You cannot find any other factorization in which there are some different prime factors. No, this factorization is unique except for the order. Apart from the order in which the prime factors occur, means you can change the order of the prime factors. You will get the same number again and again. See, 3 2s are 6, 3s are 18, or 2 3s are 6, 3s are 18, or 3 3s are 9, 2s are 18. Yes, you can change the order. You will every time you will get the same number 18, but you cannot change the numbers. You cannot change the prime factors entirely. In the next video, I'll explain you how to find the prime factorization of big numbers. Like in this example, we have very easily written the prime factorization of 8, 18. But what about big numbers like 156, like 10,892? How to find the prime factorization of big numbers? That we'll understand in the next video. And what is the meaning of LCM, HCF, and word problems based on them. So, all the best, keep studying, keep working hard, and have a bright future.